Good afternoon. My name is K.T. Ramesh, and I am the Alonzo G. Decker Jr. Professor of Science and Engineering at Johns Hopkins. I also serve as the Senior Advisor for AI to the Johns Hopkins President. I'm delighted to welcome you to this installment of the Johns Hopkins Congressional Briefing Series, where Hopkins experts provide a briefing on a topic of interest to policymakers and engage in real-time question and answers. In today's briefing, our panel will discuss some of the opportunities and challenges associated with artificial intelligence, what we call AI. Here at Johns Hopkins, we are particularly interested in AI systems that help us to better understand and improve the human condition. AI has the potential to drive incredible progress in many, many fields and to have very positive impact. At the same time, like many technologies, AI brings with it some risks and new challenges. So there's a need for us to be able to think critically to develop ways to mitigate these risks, to maximize the net benefits of AI. And informed conversations like this between experts and policymakers are essential for these purposes. So they help to drive the development of these technologies. And it's in that spirit that Johns Hopkins University convened today's briefing. As AI has huge implications across many domains, it's also important to bring together experts from multiple viewpoints, from multiple fields. And so for today's briefing, I'm delighted to be joined by 5 of my Johns Hopkins colleagues. I'd like to introduce them to you. So Professor Ilana Fatigue is an associate professor of oncology, biomedical engineering, and applied mathematics and statistics. At the Johns Hopkins Sidney Kimmel Comprehensive Cancer Center, Professor Fatigue serves as division director and Associate Cancer Center Director of Quantitative Sciences. She's also the co-director of the Convergence Institute and co-director of the Single Cell Training and Analysis Center. She directs a hybrid computational and experimental lab in the systems biology of cancer and therapeutic response. In today's briefing, Professor Fatigue will be talking about the use of AI in healthcare. Next, I'd like to introduce to you Professor Laurie Graham-Brady. Professor Graham-Brady is a professor of civil and systems engineering at Johns Hopkins and Associate Director of the Hopkins Extreme Materials Institute. Professor Graham-Brady is a leading researcher in the field of computational stochastic mechanics, in multi-scale modeling of materials with random microstructures, and in the mechanics of failure under high-rate loading. Her work includes the development of a collaborative program funded by and in partnership with the Army Research Laboratory for designing materials for extreme dynamic environments. She will discuss with us how AI can help in the design and discovery of new enabling materials. Next, I'd like to introduce Professor Rama Chellappa, who is a Bloomberg Distinguished Professor in Electrical and Computer Engineering and Biomedical Engineering. Professor Chellappa is an expert in computer vision, pattern recognition, image and signal processing, machine learning, and biometrics, who uses data, geometry, and physics to help computer systems interpret the visual world. He has a new book, Can We Trust AI, that will be published by Johns Hopkins University later in the year, and I think may even be available for pre-order sometime soon. Today, Professor Chellappa will be talking about the major challenges that need to be addressed before AI can reach its full potential. Next, I'd like to introduce to you Dr. Kara Lapointe. Kara is the co-director of the Johns Hopkins Institute for Assured Autonomy, which works to ensure that autonomous systems are safe, secure, and trustworthy. Dr. Lapointe's work focuses on the intersection of technology, policy, ethics, and leadership. During more than 2 decades in the United States Navy, Kara has held numerous roles in areas that include autonomous systems and unmanned vehicle technology integration. Dr. Lapointe conducted research in underwater robotics in the Deep Submergence Lab at the Woods Hole Oceanographic Institution. Today, she'll talk about AI in autonomous technologies. Finally, I'd like to introduce to you Professor Deborah Matthews. Professor Matthews is the Assistant Director for Science Programs at the Johns Hopkins Berman Institute of Bioethics, and she's an Associate Professor in the Johns Hopkins School of Medicine's Department of Genetic Medicine. Professor Matthews' academic work focuses on ethics and policy issues raised by emerging technologies, with particular focus on AI, genetics, stem cell science, neuroscience, and synthetic biology. She serves as the Ethics and Governance Lead within the Johns Hopkins Institute for Assured Autonomy and she will talk today about ethical considerations related to AI. So thank you all for joining me on this panel. Before I turn to each of our panelists for remarks, I want to remind the audience that we will be providing answers to your questions in real time. There'll be a space for you to submit questions for our panelists in the box at the bottom of your screen. We'll begin with each of our panelists providing a brief overview of key topics, some of the topics we've introduced already. And I'm going to start with Professor Fatigue. So Alana, could you talk about some ways in which AI is being used in healthcare? And I know you're thinking about a revolution AI in healthcare as it comes up, so if you'd care to expand on that a little bit?
Absolutely. So thank you for the opportunity to be here today and talk about AI in healthcare. We think about a lot within the Cancer Center about AI specifically within the cancer domain. So I'll focus largely on that, where what we're seeing is that we have an advance in new measurement technologies that when coupled with artificial intelligence, for example, new imaging technologies, new genetic measurement technologies, all of these features that let us really uncover humans' biology and that of their tumor ever deeper, that we can couple these types of data with artificial intelligence methodologies so that we can improve diagnosis, improve prediction of treatment selection, who's going to respond to a therapy, who isn't, so that we can select patients to go on or off therapy, and ideally sort of aim to get to a world where a patient comes in and we're really delivering healthcare based upon both those sort of clinical imaging style tests, along with all the information in classical clinical records and clinical tests as well.
Could you maybe talk to that a little more, looking in the near future and maybe the little more distant future, about what you might expect to see, perhaps an example?
Absolutely. So right now, I think we're at a point where, I think most people who can appreciate this, when they come to the clinic, they come with their scans, they come with their radiology scans, they come with their biopsies. And typically those then go off to either a radiologist to read them or a pathologist to interpret them. I think what we're seeing increasingly in the current day is where some of those decision making, at least for the sort of most extreme cases, is starting to be automated. And really sort of going to the clinician again and going back to the radiologist or the pathologist in order to figure out where are the more difficult decisions that can't yet be decided by an algorithm, to sort of use human guided judgment there. And so I think that's where we are near term. There's a number of advances in terms of genomic biomarkers and using individual genetics to tailor and match to therapies. So I think that's where we are in the immediate term. As we go to the future and think about this moving forward, we want to be where I think we're going to go is that patients' records and all of that information is going to be increasingly available electronically. And we will have computer systems with computer software that are able to mine that information and interpret that into clinical decisions, or at least a bullet set of points that are most pertinent for a clinician, that then the clinician can have this human-guided AI to interact with the system.
So you bring up something that's really interesting, and I know somewhat difficult to parse completely, but perhaps you could talk to what you see as the role of the physician and the clinician in this kind of a more complex system.
Absolutely. So, clinicians have, generations of experience and human sort of interpretation of what's going on in a patient, an ability to get information about pain, things that might not be easily measured, or the patient might not bring up, that might not come up directly in a clinical test. So I think those types of guidance is really important in order to guide, make sure that we're getting the relevant tests and the relevant information about a patient to then make a decision. But once that's in there and once we start getting those data, I think that's going to be a point where once we have sort of a robust panel of data, that we can start to imagine having computerized systems evaluate that and make complicated decisions across a number of different data modalities, combining imaging data, combining the genetics, combining these other measures that they get, and then combining that into a summary. And I think one of the challenges for AI is how do we then make that information so that it's not just a black box of this is what to do, but it's a summary of the most relevant features to go back to a clinician and make those decisions.
Wonderful, thank you. I'd like to come back to you later once the questions and answers start, but at this point, let me move on to Professor Matthews. Thank you, Alana.
Thank you.
So, Deborah, how should we be thinking about the ethical issues related to AI?
Yeah, thank you. So, I mean, in any new emerging area of science, there are a number of questions we want to ask regarding impact, including first, is it safe, right, for humans, other animals, the environment? Second, sort of overall, what are the potential risks and benefits, and how will those be distributed across individuals and groups? Will all members of the society have an equal chance of enjoying the benefits or suffering the harms? And then, does the science in question bear on sort of fundamental questions of human meaning? And if so, how might different people answer those questions differently? And how are we going to make decisions about how best to move forward so that even if everyone doesn't get what they want, everyone justifiably feels that the process was fair? So for AI, unless we're talking about like Westworld level artificial intelligence, which we aren't yet, we're largely talking about ethical issues that fall under the first two sets of questions. So first, safety. And here there are questions about, for example, autonomous vehicles and their ability to recognize and behave appropriately around pedestrians and cyclists. There are questions about the kinds of autonomous systems in medicine that we just heard from the first speaker. And then examples like those in a recent news article about a chess playing robot that broke a kid's finger when the child moved in a way that the robot didn't expect. Now, the background risk of those activities, driving, medical care, chess playing, are of course different, and so is the governance of those activities. So we might expect clinical trials to assure safety and efficacy of autonomous systems in medicine, whereas that's not generally how we approach mitigating risk in chess playing. So different approaches will be required. The second set of questions regarding risks, benefits, and their distribution across individuals and groups, of course, has some overlap with the first, since concerns about safety are also concerns about risk. But the range of risks is much broader here. Perhaps the most common issue that's discussed in this regard is biased training sets in AI. You know, we know that humans are racist and sexist, for example, and those biases are clear in our medical, social media, and other data sets. And this might lead, for example, to an algorithm determining, based on electronic medical record data, that people with certain social determinant of health profiles will do worse. And then they get deprioritized for care, sort of doubly disadvantaging them. This situation would both harm individuals and may represent unequal distribution of risks and benefits, creating justice and equity concerns. In addition, many autonomous systems don't have explicit ethics coded into the algorithms, ethics get inadvertently coded in nonetheless by the people building the systems, who, it's worth noting, are not a very diverse group of folks. And this isn't intentional, but it is pretty predictable. So for example, it's often the case that a proxy variable in the data is selected to stand in for what the algorithm is really supposed to be predicting. So for example, future healthcare costs will be a stand-in for future healthcare needs. And these choices are made by humans, and this mismatch can lead to the exacerbation of existing inequities. Another example relates to narrow or inadequate functioning. So for example, the Apple Health Kit originally didn't include a menstrual cycle tracker. And there are many other issues, of course, about transparency, privacy, accountability, et cetera, that I don't have time to go through. But so what should we do? Well, it's often the case with new technologies that ethical considerations aren't addressed until a product is on the market. And this model is particularly challenging for AI-enabled technologies because many of the ethical concerns we have are baked straight into the algorithms themselves and the data to train the systems. So we just have to move our consideration of ethical issues earlier in the process and include public voices in discussion and decision making. We also need to move beyond the standard model in research ethics and government oversight that tends to focus on individual risk and harm. Almost pretty exclusively. But the pervasiveness of AI-enabled systems raises the stakes and makes society-level impacts much more likely. So we need to develop and implement ways of taking into account these broader sorts of ethical issues, including questions of justice, fairness, and equity. And then the last point I'll make is that we should also spend some time thinking not only about the ethical issues raised by the design and application of AI, but also what are the existing ethical issues that we might actually harness AI to address?
Great. Thank you, Professor Matthews. I really appreciate that. I'm sure we'll come back to questions related to ethics later in this panel. I'd like to move now to Professor Rama Chellappa. Rama, so let me go directly to this question of challenges, right? So what are the major challenges that you think need to be addressed before AI can really achieve its full potential?
Thanks, Katie. Good afternoon, you all. I'm happy to be here. I have been involved with AI in one form or other since the late 70s when I took my first graduate course in AI as a graduate student. At that time, AI was in the middle of what is known as AI winter. And since I shivered through the AI winter, I moved to other fields like computer vision and so on. And of course, AI has come back. It has evolved over the decades. First, we were doing logical reasoning, and then we went to probabilistic models. The modern AI is mostly based on data. We are mining data for reaching decisions and predictions and so forth. So that's why we have to address a new set of challenges, right? Because data is not always perfect. The sensors are not perfect. And as Deborah mentioned, there may be some biases that creep into data and so forth. Data-based AI is also now mostly functioning as a black box. Data goes in, decisions come out. And Elena mentioned about the interpretability of such decision-making process. Interestingly, the traditional AI was more interpretable. We would have logical rules, probabilistic models, and so on. When we move to the better performing data-driven AI, we have lost some of that, and we have to regain that. Okay, so what are the four big things that I worry about? Since I shivered through the AI winter in the late 70s, I always worry maybe another winter might come if you are not careful. So the first thing I worry about is what is known as a domain shift or data shift. In pathology, for example, there are many, many labs that produce specimens and images and so on. They're slightly different from each other. If you train on one kind of lab data, does it work well in other data? In the case of autonomous driving, we may make it run in the suburbs of Iowa, or will it work in Mumbai? Will it work in Hong Kong? What do we have to change? In some countries, they actually drive the wrong way, right? So the cars have to be tuned to that. Now, can we tune a car for every city, every state, every country? So domain adaptation, adapting to different environments that the autonomous systems, the AI systems will have to operate. Answering the question, will AI work everywhere? Is one of the things that I really worry about. Think of Alexa, for example. When it comes to you, it doesn't know how well you speak English or what your accent is and so forth, but they have to kind of have a broad protocol to kind of survive, right, in new environments. So we see that every time that data-driven AI is there, whether it's going to work everywhere. So that is a major concern that we have to address. We have been working on this problem for a decade, and many other researchers at Hopkins and other universities are working. We're coming up with new methods for domain adaptation, adapting AI system to new environments. Okay, that's very important. Humans, we are good at that, right? When we go to a foreign country, we kind of know what to expect, based on how we have lived so far. There are always some unexpected things, but we adapt. So AI has to do that. Second one is vulnerability to adversarial attacks. If you put a little yellow sticker in a stop sign, the autonomous car may think it's a 45-mile speed sign and may just run, across the stop sign, and that's not good. So, many of us are working on protecting the AI systems for various kinds of attacks. Now, this is a cat and mouse game. A whole bunch of attacks come and we provide defenses, and then new attacks come, we provide defenses. It's not And very similar. It's very similar to what happens in cybersecurity. Also, new attacks come, we have to build new defenses and so on. So this is the second issue that I worry about. But we are working on this, and many others are. Deborah mentioned a lot about bias. I have worked on face recognition, and I'm very, very sensitive to the issue of bias. In 2018, there was an MIT report that pointed out that some of the existing commercial face recognition systems did not do well when it was doing gender classification for dark-skinned females and males and so on. So that worries a lot. So we are developing methods for evaluating where the source of bias comes from in face recognition. Is it the balancing of data, or the loss functions that we use have to be changed, the training procedures have to be changed, and then provide methods for bias mitigation? This is a tough call. You may have a bias system that performs very well, and when you reduce bias, the system performance may go down. So we have to remove bias at the same time maintain performance, right? Only a performing system will get accepted. But we have to pay attention to society's concerns about bias. So this is a major issue. The fourth issue, of course, is privacy. Medicine has worked out very detailed protocols about how to maintain data. But some of the computer vision systems, like face recognition, faces are collected sometimes from the web and so on, and systems are being built. So everybody is worried whether their data is being used in training AI systems. So we have to make sure such privacy concerns are taken care of. One thing I like to say is that AI is here. It's here to stay. It is doing good things in a lot of ways. It is not the perfect technology, right? For example, you take the autonomous car. We may not have a fully autonomous driving car that works everywhere. So you can, read your book and drink coffee, and then it's still okay. But the process of getting there has helped us to figure out how to design new sensors on your cars. So when you change lanes, you get alerts. Or if the car thinks you are going to hit the car in front of you, it gives you an alarm. Or if you change lanes without the turn signal, it brings you back. These are all safety features that have been put in cars, even inexpensive entry-level cars, because there was a goal of reaching fully autonomous car. So 80% autonomy is still good. Okay. So we have to keep that in mind. AI, the problem with AI is everybody thinks it should do everything perfectly. There's no such thing. There are always trade-offs. The last thing I would like to mention is, for AI to be really integrated into society, we have to understand human AI interaction. How does a clinician interact with AI? And there is a triplet, a clinician, AI, and the patient. So how do we convince the decisions made by the AI are good for the patient? So this interaction is very important. It's everywhere whenever AI is introduced, in medicine, in forensics, and everywhere. So we have to look at that. And of course, the AI is considered to be a black box now. It's getting better. We have to be able to explain how the decisions are made. So I consider these as major challenges. I think we are going to slowly work on all of them, and slowly things will get better, but we need to give it some time. We cannot go and tell a 2-year-old, AI is not a 2-year-old, it's almost reaching Medicare age. We can't say it that, it should, 2-year-old doesn't know calculus, therefore the kid is not smart. No, that's not true, right? So let us give it time. Concerns are real. Let's work on it. And thank you very much. I'm happy to take your questions later on.
Thank you, Rama. Appreciate it. That was very useful. I'd like to move now to perhaps a real-world application, perhaps an application in the physical world, to Professor Graham Brady. So, Laurie, I'd be grateful if you'd talk about how AI can help in a specific case. So I know you are interested in the design and discovery of new materials, and perhaps you'd care to talk about that.
Yeah, perfect. Thank you, KT. So I think materials are an excellent example of where you have a highly complex design process where AI can make a significant difference. But at this, I guess I would like you all to think more broadly than materials, that across engineering, there are a myriad of complex design and discovery challenges that you can imagine. So with that in mind, actually, I did have a slide. So I'll walk through materials design, but to give an idea of how this translates to other areas, I have some parallel comparisons for the design of one of my favorite man-made inventions, the cookie. So if you prefer not to think about materials and you like cookies better, this can tie in as well. So if we think about traditional trial and error design of materials, it goes something like this diagram. You first start by making a selection of a particular chemical composition, or you can think alternatively of the ingredients in the baking analogy. And then we decide how we'll mix, fabricate, heat, roll, process the material, similarly for the cookie. This recipe will dictate the structure of the material at the small scale, which could be assessed using advanced microscopy and other techniques. You could also think of, in the cookie case, you're assessing its color or its crunchiness or how burnt it is. And then finally, the material can be tested to determine if it has the desired strength or stiffness or conductivity, whatever properties, whatever it is that you were hoping to get out of that material. And of course, taste testing is great with the cookie example. And finally, there's a feedback loop to the beginning. So none of this is new or AI specific, but I kind of wanted to walk you through this process because you can see problems here. All of these processes are highly manual. There's a lot of rote human activities and expert judgment required. Can we speed up those manual processes? You can imagine there's an infinite number of possible material or cookie recipes. Can we explore those recipes more efficiently? And what should we do with the feedback? So if the material is not performing acceptably, or the cookies taste terribly, how do you decide what is the next best process to try? So that's where I think there's some really interesting engineering challenges when we think about trying to develop a system that can rapidly design new processes or new components or new materials that we don't tend to think of as much in classical AI. So in recent years, we've seen significant progress in developing automated processes, such as additive manufacturing of materials, automated preparation and manipulation of material specimens. And this automation is great. It can speed up a lot of processes that have traditionally required someone, and I'll say otherwise known as a graduate student, to conduct rote, time-consuming operations. But just because we can speed these processes up, it doesn't mean that we're necessarily speeding up design significantly. So if we have no capability to make decisions about the next design or the best way to evaluate our materials, an enormously wasteful number of specimens will be evaluated. And we'll have little confidence that we've actually been very effective at exploring the possible material designs. In other words, we lack insight. And so a classic way to develop insight is through developing models that give us those insights. You can look at a model that tells us a lot about what's going on in materials at the small scale and particular events and how we might improve the future materials. But those models can take hours, days, weeks, months to run and to evaluate. And we don't always know how much confidence we have in those models. If we have an automated system that relies on a full physics-based model, we face enormous downtime just waiting for the models to guide us on the next steps to take. So this is where AI really comes in, and I'll first start with just machine learning. In my experience, it's emerged as an amazing tool to provide faster predictions. My students are looking at machine learned models that can predict stress distributions and composites in less than 1% of the time that required by a physics-based model, and the results are really good. So these accelerated models make it feasible to say, look, I'm at a crossroads, I have to decide what to do next. And those models can actually probe all the different paths you might think about taking, and from there, identify through AI-based tools, what's the pathway that we can take that will give us accurate and rapid decisions. So not just about like what's the next best material, but even how we might improve the process itself. So there's a feeling that so much has been accomplished in AI, and why is this problem any different? And I guess I'd like to point out that in materials, and I think in a lot of engineering applications, there are a few things to keep in mind. The data associated with these materials is really expensive. You're using state-of-the-art equipment, so therefore, the data is typically really sparse. So it's not like the large quantities of data that AIs like Waze or Google use, where you have huge numbers of data. The data is also heterogeneous. So it's got, columns of numbers and images and text and video. So you really need novel machine learned / AI approaches for sparse but complex data. And that's really key to the engineering design of materials, but also for many other key engineering applications where these operations are expensive. So I think I will leave it there, but thank you everybody for giving me this opportunity.
Thank you, Laurie. Appreciate that. I'm sure we'll come back to some questions there, particularly with respect to where industry might go, for example. I'd like to switch now to Dr. Kara Lapointe. Kara is an expert on autonomous systems, and I know you've been working a good bit about thinking about the safety of such systems. Would you care to talk a little bit about how you assure the operation of an autonomous system?
Absolutely. Thank you, KT. And if we could bring up the slides, often when we're talking about autonomous systems, people ask the question, what is the difference between AI and autonomy? And the way that I like to think about it and explain it is, Rama earlier talked about AI being this black box. There's this model in a black box, and what you put in is data, and what you get out is some usable information. But the way you use it can be different. So you can use it to increase awareness. So I like to use this example of some kind of mapping algorithm. If I put the traffic layer on and I can see where there's slow traffic, there's fast traffic, that output of that AI model that's giving me this information is explaining to me more about the world, right? It's giving me more situational awareness. And then what I do with that is, human decision. So the next way that AI can be used is AI can actually recommend action. In this case, if I'm in Manhattan and I want to get from Penn Station and go over to the UN headquarters, it can recommend several different routes, and it can optimize for different things. It'll tell you, this is the most fuel efficient route. This is the fastest route. This is the route with no tolls. So that is when an AI system, so there's AI at the heart of it, and it is recommending action. And then the third piece is what I spend a lot of time thinking about, and it's autonomy. And that's where the output from the AI model is actually being used for machines to act without human intervention. So these systems are acting on their own, right? So think about a self-driving car. If I'm trying to get from point A to point B and I have a self-driving car taking me, that is a system that is acting without human intervention. So as we've heard from all of the speakers, it is really important that safety, security, all of these things, the fairness, ethics of these systems are very important. It is particularly important for autonomous systems where human judgment is not in that actuation loop, right? Where systems are acting on their own. So if you can pull the next slide, please. So it's really important that we think about the technology, and we've heard we need to make technologies safe and reliable in the unconstrained world. And Rama was talking about, is it that possible to kind of generalize it to all environments? So that's really important. We heard about things need to be secure and resilient against attack, whether that's hacking attacks, whether that's kind of image and sensory inputs where people are changing that stop sign with some stickers. That's really important to make sure these technologies are going to work in the unconstrained world. But also we have to think about that world, that ecosystem that they're going into, because these systems are not just operating in a field somewhere. They're operating alongside humans. They're operating alongside other autonomous technologies. They're operating alongside and within this whole infrastructure of our lives, whether it's technical infrastructure, economic infrastructure. So these systems have to work in context. And finally, we have to think about the ethics in all things. We have to understand all the things that could have the kinds of impacts we don't want them to have. And we have to think about the governance mechanisms, policy, legislation, all these different governance mechanisms we have. And so you really have to think about these things strategically and how do these things influence one another? So instead of having a serial generation where we develop technology, we implement technology, things go wrong, and then we start to create policy and legislation, how can we start to co-develop and co-create those things? So this is what we really have to think about when we're trying to make sure that we can assure or ensure that these systems are safe, secure, reliable, ethical, and trustworthy. So if you can go to the third slide, this really leads to, you can see just at the top, we have this kind of a holistic framework of assurance, right? In terms of all of those attributes that I talked about are really important. So I just want to show you some examples, and I'm not going to go in detail, but point out the types of research that we're doing that align with those different pieces. The two graphics on the right represent research that's being done in really to make these systems safe and reliable. We have teams on the top right that are looking at ways to make sure you have a safe operating envelope when physical systems like autonomous vehicles are going through the world, to make sure they literally don't run into anything else, right? The bottom right shows where we have design tools that, you think about anytime you try to update software and you go to fix an issue you have, you might introduce new issues, right? So we need tools and ways and research into how you can ensure that you're getting rid of the issues and not introducing new ones. On the bottom left, we have teams looking at exactly what Rama was talking about, where if you have these kind of attacks on your image inputs, you can make sure that the systems actually recognize the world for what it is, even if there are, the images are rotated or transformed in some way, or somebody kind of obscures the image. We need to make sure these algorithms are robust. So if you go to the final slide, please. So some other types of research up on the top, it shows we have teams that are looking at these privacy and the fairness issues in terms of images. They're looking at facial recognition sets and how do you make sure that those facial recognitions work regardless of population. And we often think of performance and privacy as a trade-off, but what our teams are showing is that there are ways to make these algorithms work almost as well or even better and still get fairness between groups, especially thinking about marginalized and vulnerable populations. Right. And then on the bottom left, we have teams that are looking at policy, that are looking at how can you, this is an example in Baltimore where, the status quo is on the left when it comes to food deserts, where there are more food deserts and kind of access to medical care. With the right policy, as autonomous vehicles come online, can you improve that? Right? Can you actually ameliorate the situation instead of just exacerbating some of the negative impacts we have already? And finally, on the right, it's just an example of research where people are looking at airspace. And when we think about all these autonomous delivery drones and from all different companies that are trying to do that, how do you make sure society is safe with all these different systems operating in concert? Right? So these are just some examples of the many, many different types of research that we need to do and are doing to ensure that autonomous systems that are acting without human intervention are safe, secure, reliable, ethical, and trustworthy across society. So with that, I'll hand it back to KT.
Thank you, Cara. Appreciate that. So we're going to move on to take questions from the audience. So we'll look at questions that viewers have submitted. Please keep submitting your questions as you go. I'm just going to direct the questions to members of the panel as the questions come in. So let me start with this one, which I think is really interesting, particularly given where Congress is with the science, the bill that was passed with Senate yesterday. So NSF, the National Science Foundation, is going to have a new directorate, and that's going to be focused on new critical and emerging technologies. This is our understanding. AI certainly falls into that category, right? Critical and emerging technologies. And the question was, in your opinion, is there research within AI that this new directorate should look to focus at in the early stages? And I'm going to direct this one to Rama. So Rama, if you want, can you talk to where you think the new directorate should be going for critical research topics?
Yeah, I think what's important is, I mentioned many concerns we have as AI researchers. For AI to be accepted, whether the society accepts that as a technology that improves their life is finally will decide whether the technology can sustain. No, you cannot sustain a technology that causes harm, right? So we need to look at things keeping in mind for societal good. AI for societal good. It's not just making my car run faster, or I can make my espresso when I'm sitting in the car and don't pay attention to the traffic signals. No, those are all fine. But society takes healthcare or improving education. In fact, AI can play a big role in helping folks with disabilities, with learning, disabilities. So, in fact, somebody asked me a long time ago, what is my big moonshot? I said, I want a class for students with one physical teacher and 30 virtual teachers. Each virtual teacher specifically looking at each student and then working with the students, individualized, education and so forth. So, because what happens is in classes, they can't do the extremely brilliant ones, and very, people are not doing it. They're always focusing in the middle. So it's an issue in education. So we can also look into people with physical disabilities, provide wearable sensors. So I think that is where AI will be seen as giving a real boost to the quality of life. That's what I will focus on.
Great, thank you, Rama. So there's a part in there about also being able to have impact at scale. I think that was your education example. It's a very good one. Let me take a second question here. So, and I'll direct this one to Ilana and perhaps Deborah, but let me start with Ilana. So how will AI change the way in which medical professionals work with their patients or care for their patients?
So I think if I think about how AI is going to change how medical professionals care for their patients, I think there's sort of two pieces to that. There's what is the information that medical professionals are getting when they see patients versus what does it look like for a patient coming into the clinic. And I think it's very important for our patients, and as we think about clinical and medical practice, that it not become a robotic system, right, where patients go in and are seen by a robot. I don't think anybody wants that. I think that human interaction is still very critical for getting compliance on therapies, getting comfort, getting information that you can't necessarily get in other ways. I think where I can see AI transformations making a huge revolution on medicine is what is the relevant information that the clinician has access to. So they're going to have access to what their eyes and ears are telling them when they see a patient, but also really just a summary of most relevant features so that they can get to better information to care for patients. And, the other avenue that I could see changing is maybe some more minor, there might be some interactions where we can figure out, does a patient need to come in, and thinking about not only what are the features that a patient is seeing, but what is the frequency, what are the types of routines for checks that are going to be specific to a patient for follow-ups in medical care?
Great, thank you. I think I'd like to move on to a third question which relates perhaps, and maybe I'll target this towards Kara. So the question is, what checks and balances for AI technology are in place or are needed to maintain control of AI-based systems?
Absolutely. And we think of these systems, AI-based systems and autonomous systems, throughout the life cycle. So you go from the very early design through development, through operation. There are different tools at each of those stages. So there are different ways that we have in terms of doing test and evaluation for these systems that are some of the important controls. But you cannot design out all risk in autonomous systems and AI-based systems. So we also have things like monitors that do real-time monitoring of AI systems, and you have governors that would step in if you're starting to see emergent behaviors. So there's a whole range, and we're still developing more tools, but there are already a whole range of tools that we can make sure that these systems are safe.
Thank you. I was curious looking at that question. That I think there's this underlying idea that we might lose control of an AI-based system is something that is being brought up there. And the question of continuous examination of that process is a good one. Let me take a fourth question here, and this is back in the healthcare domain. So regarding predictive imaging, are there quality and patient safety measures already in place? And I'm going to ask Ilana to start with that, and then Deborah to follow on from it.
Yeah, so anything that we're using for clinical decision making does have quality and patient safety measures in place. So the FDA monitors all AI-based algorithms as considering them as medical devices, and they go through a set of rules and quality assurances that go through approval and checks in the same way any other pharmaceutical or any other intervention is given. So patient safety is first and foremost to anything that's in clinical practice. With imaging, certainly there's variation in terms of the quality of imaging and the type of imaging that's obtained in different centers, in different medical centers. And so it's going to depend, what approach you use is going to depend on the quality of the imaging that's obtained. And again, that's going to be something that's monitored and is a very active area of research that people do of comparing reliability across centers and comparing how things perform on different bases. and you were talking earlier about where priorities are need to be for funding, I think one of the things that people undervalue is, as we're thinking about AI, how do we benchmark it against, different quality data types or different data sets from different areas? It's a lot less exciting, I think, than thinking about your next algorithm. But for clinical decision making and patient safety, it's absolutely critical.
Thank you. Deborah, would you like to add anything on the safety side of that discussion?
Sure. I mean, I'll say that, we've talked a lot about, I think in multiple of these different questions, something that's sort of at the core that we haven't really touched on much yet, though Rama brought it up in some of his remarks, is trust in the system, right? And how much do physicians, patients, drivers trust the system they're interacting with? And what are the steps that we need to take? What are the questions that NSF should be offering funding for that will help us understand why and when and how people will trust these systems so that they can actually be implemented toward societal benefit?
Thank you. Actually, this relates to the next question that came up, which is in part the question of the public perception of AI as compared to the expert or the scientist perception. So the question specifically is, do you think AI will be more or less trusted by the general public compared to scientists? And maybe I'll start with Carol on this one.
Yeah, so when we started to think about assurance of autonomy, we really dug into the question of trust, right? And there's kind of two sides to the coin in trust. There's building trustworthy technology, but there's also understanding what it takes for people to trust. So I think one of the things that's really important is that these challenges that we have with AI are not things that we can solve in just the technical realm, right? This is where we have to be multidisciplinary and bring together both technologists and social scientists and even humanists, right, into this equation. And as we've done research on what does it take for people to trust, one part of it is the trustworthiness of the technology. Other pieces are the trustworthiness of the organizations that are bringing the technology, the individual user experience, and also priorities of communities. So one of the areas we need to really focus better on is to understand in kind of more real time and in context, what are those priorities of communities? What do people actually trust? Because often what people say they trust is different what they really do trust. And the cultural competency of AI systems is really important because trust does not always translate from one community to the next. So these are really some of the cutting edge research areas that we need to focus on.
Katie, if I can add.
Yes, absolutely, Rama. I know you have a book coming out on the trust of AI. So I do want you to jump in this.
Yeah, I think part of the reason is the public gets its perception of AI from James Bond movies and flying cars and robots that go and kill people now. So I think as people interact more and more with AI, even people who drive Tesla, right, the fully automated, they're not so sure yet because they have heard suddenly it breaks, software is a new software, or it accelerates and so on. So I think as it gets slowly integrated into our daily lives and so forth, I think people will trust it more. That's where it has to be. But then anytime you introduce something like that, there are some consequences. Nothing works as it should all the time, and so on. But one thing I also worry about is that there are so many accidents, car accidents in United States for various reasons, several thousands. But the moment Tesla goes and knocks a cow off the road, oh my God, that becomes a front page thing. Tesla killed a cow and so on. So people get worried. What's going to happen? So I think we have to slowly, get used to it, but it'll get better. They will see improvements in healthcare. They will see improvements in day-to-day operations, managing their lives and so forth. So I think I'm optimistic.
Thank you. Deborah, do you want to jump in on this one?
Yes, thank you. I just wanted to sort of friendly amendment. Yes, people absolutely get their views on AI from the media. I mean, my teenager was like, haven't they watched all the movies? Don't they know where this goes? But it's not just that, right? People do read the news stories about certain communities of color being disproportionately denied mortgages or bail. Like these systems are having concrete negative impacts right now as well. They're absolutely having concrete positive impacts, but we need to be attuned to the way these systems are affecting some communities as opposed to others, and take into account the fact that we live in, a structurally racist society, and we need to keep that in mind as we're developing these technologies and engaging with communities about them.
Thank you. I'd like to move on to a different topic, and this has two parts to it. The topic in part is the question is, are there specific specialties, specific directions that will be most transformed by AI? It's not clear to me in the question whether they think about healthcare specialties or specialties in general. But I'd like to direct that a little bit towards Laurie in particular and see if there are directions that you think of in industry and in the physical spaces that you work in where you think there'll be major impact.
Yeah, that's an excellent question. I think when we think about industrial applications, there's both processes and components, right? So industry is in the position of trying to develop new processes as well as a widget. Both of those are being developed typically on expensive data. It's not something that, you have a billion people in the world that you can take data from. It's something that they have a limited data set to work with. And it may be pretty uncertain data. So dealing with that is a real issue for, I think, industrial applications. I think something we have to think about is when we think about AI and autonomous systems and automated systems, what that does to the labor force. And I think we want to think carefully about human AI automation collaboration, and where the human judgment comes into play is a really important part of that whole equation.
Thank you. And maybe a version of this question that is a little more health related. So what do we think of as the roles of the private sector and the relationship that public health professionals will have with the private sector as things move forward? Let me direct that to Kara first. I'm sorry, to Alana first, and then go to Rama.
Yeah, so I think that, public-private partnerships are going to be really important in this. And, there is a lot of data, you're right, Apple Health, other wearables that come in that really give much more live monitoring than we can ever hope to collect from the medical records. So, we need new technologies that are going to enable us to work with them, with those wearables, which are being developed both in the public and private sectors. As well as then how do we get that information in, right? Is it proprietary? Is it there? How do we really start integrating them and get the hospital medical records data interacting in more effective ways with the medical data that's being collected from these sort of sources, but do it in a way that maintains patient privacy, that respects patients, that respects their medical information, and doesn't necessarily commercialize it or make it fully available. So there's a lot of ethical challenges that we need to consider within that. There's also, I think, a large role for public-private partnerships in terms of, even some of the genetic basis of understanding medicine, where, working with pharmaceutical companies, working, really in partnership with academic medical centers and other centers, can we get larger cohorts in clinical trials to really understand why are some therapies working really well for patients but not working well for others, so that we can start to advance the next therapy is going to be absolutely a critical area. So I think it goes across all sectors, both from the algorithm side to the data side and to the basic fundamental biology side as well.
Thank you. Rama, would you care to comment on the private sector health side?
Yeah, I think what the private sector does with the data is what we need to worry about. If it goes to a hospital, they probably look at it, they may suggest better treatment and this and that. For example, there's a new thing that if somebody is a diabetic, their blood sugar results in the morning can straight go to a central place. They allow that. They say, oh, that way we can monitor. But the question you have to ask is, immediately will I get recommendation from my supermarket, which particular health bar I should eat or which less sugar? That thing is still there because they're collecting data. I mean, I was at a at a conference with the Gary Witta, the guy who co-wrote the Rogue One Star Wars, and he was he freaked out because he said, I was talking about buying a mattress. Alexa heard it, and the next time he logged in, he's getting all this recommendation about new mattresses. I said, well, welcome to the reality show, right? So I'm fine. If Apple collects my data, it's with me, and it tells me, Rama, maybe you need to do a little bit more exercise today, I'm fine. I don't want that data to go to the supermarket and all the guys who sell stuff and sending me coupons and so on. That's where I worry about.
Thank you. Let's take a final question here. I know we're running close to the end of time here, and I'm going to ask all of you to speak to this because I think this is one that we all resonate to some degree. So the question is, what should we be teaching our kids about AI? And for the purpose of this question, let me assume you're talking about kids who are, teenager or less. So let me start with Carol. Carol, can you hear us?
I would teach them that AI is not all about technology. Yeah, can you hear me or no?
We can.
Oh, okay. I would tell them that it's not all about technology. It's really about thinking about AI as a teammate, right, as we go through life, and how AI can augment, what people do.
Yeah, thank you. Deborah.
Yeah, I would start with AI is not Westworld. That's not what we're talking about. And somewhere between sort of cautious optimism and a healthy skepticism, depending on how, not as much the AI, but how the humans use the AI.
Thank you. Laurie?
Yeah, that's an excellent point. I agree. I would say that first, the movies aren't dictating what AI actually will or won't do. It's an incredibly powerful tool that can enable a lot moving down the line here. But I think that cautious approach is great because we can think carefully about the many pitfalls that are associated with over-reliance on AI.
Lana?
I think, demystifying it to some extent, right? Like we teach mathematics, we teach statistics in our schools. There's no reason that our kids can't be learning AI, learning some basic programs, learning some basic code and getting, familiarity with that, a part of curriculum, even at a high school level or younger, to understand the limitations and where it works and where it doesn't.
Thank you. Rama?
Yeah, AI as a technology brings in domain expertise, potentially brings in data, brings in many things and so on. So it is something they should kind of get very excited about and learn. It's cool, it's fun. And of course, they should also learn, some of the things that could go wrong with AI as with any other technology. But future job prospects, right, are bright. And then, it's very hard now. It's not knowing AI, for example. I tell you, I'm in the electrical engineering department, and I teach an AI course, 70 students, mostly from engineering, because they realize they need to know what this stuff is all about, right? It's going to permeate more into the engineering thing, not computer vision or natural language processing or robotics, traditionally seen as computer sciencey things, is going to make a lot more impact in engineering. And Lori is one example of that. I can see it doing lots of stuff in all sectors. So this is a technology they should learn in high school or even junior high school, because they do programming these days, PyTorch and all that stuff. So they should take it, learn it, be excited by it, and make it better, make it work for everyone.
Thank you. I would say a little bit myself. I do think giving them a sense, not just of the power of the technology, but of the potential it has to help them in the things they want to do as humans. So to free them from some of the other things they might do and focus on the things that they might really enjoy. I think there's a great deal of positive in there, but we do want them to be aware of what the pitfalls are, what issues come up. So we have to be very careful about ensuring that they see a broad view of AI. I think we've pretty much run out of time here. So I'd like to thank the panel here, Ilana, Deborah, Rama, I guess I should say your whole names, but I think we all know each other by now, Laurie and Carol, for joining me today. And I'd also like to give a big thank you to everyone who's attended this briefing. I know I gather we had a couple of hundred here, and to those who submitted questions in particular for our experts. My understanding is a recording of this event will be made available on this website, which is just on the tag down there. The website is the online home of the Johns Hopkins Congressional Briefing Series. So thank you very much, and on behalf of all of my colleagues on the panel, thank you.
Thank you.
Thank you.
Thank you.